Alright, this video is going to be about energy. You might say that I've got energy, I've got a lot of energy. And that would be certainly true because, well, humans use a lot of energy. We're going to look at two main types of energy, I guess. You probably already know what those are. If you were to guess, you would probably tell me both of them, maybe. I know you've heard about them before. But the first one we're going to talk about is kinetic energy. So this is our equation for kinetic energy. Kinetic energy is the energy associated with the motion of an object. So I guess I should step back, and I forgot to talk about what is energy itself. So let me go back here for a moment. Energy. Energy is, if I were going to give a definition for it, energy is the ability to cause change, or as we're later going to find out, the ability to do work. So we kind of know intuitively energy is like, oh, I get up and run around. I use energy to do that. If I do lots of stuff, I'm going to run out of energy. So we kind of know energy, but it's the ability to cause change or the ability to do work. But it is a physical quantity that we can measure. Kinetic energy is a specific type. So kinetic energy, as we said, is the energy associated with the motion of an object. Objects that move faster have more kinetic energy. And what you notice here is that the equation, you have kinetic energy is 1/2 mv squared. This is kind of interesting because previously, I guess, a lot of our equations have been what I would call linear. You know, it's like F equals m times A or m times V. And these sort of things. But here we actually have, it's not linear, right? This is actually quadratic or exponential here with the velocity. And that shows you that velocity plays a bigger role in kinetic energy than mass does. Mass is only put in there on its own, whereas velocity gets squared and put in there. So you can see that velocity does play a larger part in the kinetic energy. I want to look at the units. What are the units of kinetic energy? Let's see what that is. So we're going to do our unit analysis. And again, I would encourage you to pause the video here and try to do it on your own. See what you can get. My hint to you, if you're a little lost, is just ignore the 1/2. Because yes, the 1/2 is there for the magnitude. But when it comes to the the units, 1/2 doesn't have a unit. So it doesn't really matter. Again, so I would pause here, try to see if you can get the unit for kinetic energy on your own. Alright, so here's what we have. We have mass, which should be in the units of kilograms, times velocity is the unit of meter per second. Now, if you stop the video and try to do it on your own, you might have messed up here, because this whole thing gets squared. Okay, it's not just the top, or it's not just the bottom, it's the whole thing gets squared. Both top and bottom of that unit. And so when I do that, you just square the top and square the bottom. And so you get kilogram meter squared per second squared. And that is the official name, right? Just like I don't know, that would be like a whole name, right? We have sort of a nickname for this. Kind of like we did with force. We have a name for this, and that's going to be called a joule. And that's typically what I'm going to be using, going to be talking about. And that symbol is just J, a joule. It's named after a scientist who did a lot of work with energy, and particularly did a lot of work with heat. And worked on different engines, creating different heat engines. So a joule is the unit of energy. And a joule is shortcut for saying kilogram meter squared per second squared, because that would take a long time and we don't want to say that every time. So we say joule. Alright, so it says, let's do a little practice. It says 200 kilogram man sprints with a top speed of 0.1 meter per second. What is his kinetic energy? Alright, well, he's sprinting with a top speed of 0.1 meter per second, which isn't very much, but the man is 200 kilograms. That is roughly 440 pounds, I believe. So, that's not so bad if you're 440 pounds. And he's working on it. Well, let's see what we get. We know that kinetic energy is 1/2 mv squared. And let's plug in what we have, or substitute, I guess I'm supposed to say. 1/2 times the mass, which is mass is 200 kilograms. Of course, all these are in standard units, so I don't have to convert anything. Times his velocity squared, 0.1 squared. So we end up with 100 times 0.1 squared, which should be 0.01. Excuse me. And you multiply 100 times 0.01, and you're just going to get 1 joule. So this guy has 1 joule of energy, of kinetic energy. Simple enough. Let's look at this, though. It says a baseball has a kinetic energy of 200 joules and a mass of 0.25 kilograms. What is its speed? So here I give you the amount of energy. I give you the mass, and we're looking for the speed. Now, just off to the side here, I think you remember this, or you should, but velocity is not the same as speed, but it's close. Remember, velocity is a vector, speed is a scalar. So velocity has direction, speed doesn't. So you could actually say that the absolute value of velocity is equal to speed, and that would be true. You could also call this the magnitude. The magnitude of velocity is equal to speed. All that is to say that really in this equation, kinetic energy equals 1/2 mv squared. We're trying to find the velocity. Alright, well, we know the kinetic energy is 200 joules. The mass is 0.25, or 1/4 mv squared. Alright, 1/2 times 1/4 is 1/8. So you have 200 equals 1/8 v squared. So we're trying to get v squared by itself, so I'm going to divide by 1/8, which is the same as multiplying by 8. And I get 1600 is equal to v squared. Okay, well, to get velocity, we take the square root of both sides here. So we take the square root of 1600 and the square root of v squared. Square root of 1600 is 40. Square root of v squared is just v. So you get 40 meters per second. I wanted to talk about something real quick. I forgot to talk about it earlier. And that is energy a vector or not? Okay, so we have kinetic energy equals 1/2 mv squared. Well, what happens here is obviously mass is a scalar, velocity is a vector, but we're squaring velocity. And so remember, to indicate that vector, we typically used a sign, whether it's positive or negative. And what's going to happen, let's say velocity is -2. Let's say it was going 2 meters per second south. All right. So when we put that into our equation, we would have 1/2, I know it's a 10 kilogram object. All right. So we had 1/2 times 10 kilograms times 2 meters per second south. But since it's south, it's got to be negative. But that -2 is going to get squared. Well, -2 squared, so we positive 4 times 10 is 40, divided by 2 is 20. But notice that that sign is now gone. When you square a vector like this, when you're squaring a vector, it kind of loses its vectorness, right? It no longer has a direction. And so all that is to say that kinetic energy, or energy in general, is not a vector. It does not have direction. It is a scalar. So we have 20 joules. It just is. That's the amount of energy. But it doesn't have a certain direction. The other thing I want to say is I want to show you this real quick. Let's say you had I'm losing my train of thought. Oh, yeah, that's what we're showing. Okay, so let's say that you had some object. Okay, again, let's just say object 2 kilogram. Okay, 2 kilogram object. And you threw it at 2 meters per second. What would be the kinetic energy of that object? Well, we can figure out real quick. 1/2 m times v squared. Okay, 1/2 and 2 cancel. You just get 4 joules. Okay, so if you have a 2 kilogram object though at 2 meters per second, you have 4 joules. That's how much energy that object has, how much kinetic energy it has while it's moving. What if we double that? Double the speed, that is. So now we have a 2 kilogram object at 4 meters per second. Well, if we double the speed, what do you think is going to happen to the energy? Traditionally, with a lot of other things, you might say, well, I think it's going to double. But you would be wrong. Because of this squared part, remember, it's 1/2 mv squared. That squared part means that if you double the velocity, you quadruple the amount of energy. And so again, that's a little different than the way it's been in the past. And you can see that here. Because you have 1/2 times 2 times 4 squared. Okay, well, 1/2 times 2 cancels again. 4 squared is 16 joules. So again, you can see it quadrupled. By doubling the speed, you quadruple the energy, which is something that's a little different. And I think I'm going to wrap it up there. Thanks for watching.